Okay, so we're going to start the next session. So it's my pleasure to introduce Lennart Augustsson. He's at Epic Games and he's working on Verse, and he's going to tell us a little bit about it.
All right. I guess I need to stand here. Okay. Yes, so thank you for inviting me to talk about Verse. There is a lot of people involved in this. Not all of them at the same time, but you might recognize some names on this list. So, what is Verse? Well, Tim Sweeney is the founder, majority owner, and CEO of Epic Games. He's also a programming language nerd, so it's quite nice to work for a billionaire who likes programming languages. And so he's been thinking about this language for like 20 years. And then I guess he decided he needed to hire some people to help sort out some theory bits and implement it and so on. And when you're a billionaire, you can do that. So yeah, so here's a bunch of things. So our job has been to try to extract from Tim's brain what Verse really is, because it's really only been in his brain. I mean, it's very well thought out. And we have our weekly meeting with Tim, and every time we have one of these meetings and we suck this out of his brain, we end up like this. There is a lot. So it's a functional logic language like Curry or Mercury. It's declarative. I mean, a variable stands for a single value and it doesn't change over time. There are assignable variables as well, but the main thing is more sort of the pure ones. It has lenient evaluation. I'll come back to that. So it's but in between strict and lazy. Things don't happen necessarily in the order you write them. The compiler can choose which order to do things, but at the same time, it's not like lazy. Everything will get evaluated eventually. It has a very unusual static type system where types are first-class values, and there's also an effect system. So there's so much to talk about Verse, so I'm going to try to get through some of the unusual bits about Verse. So it's interesting to see what choices someone who is not in the traditional programming language sort of group does, like, because Tim has designed this language and everything fits very nicely together, but some of the choices are unusual. Just to give you some quick flavor, I mean, it's nothing strange about the syntax. It's like you could imagine integers. There are tuples. Verse doesn't distinguish between tuples and arrays. They are all sort of a number of elements of things. They can have different types of the same type, which is a nightmare for the type checker. So anything where you have a variable that follows, but that is followed by a colon, means that you're doing a binding. So for instance, you can say x colon equals 3 and then x plus x, or I mean, you see some other variations. And the bottom one, you can also say something like x colon int, which looks like it says that x is an integer. And you can think of it like that, but it means something different. But I mean, really, it means that. I'll come back to what it actually means. Y equals x plus 1, and then you can say x equals 3. And that equals there is sort of a constraint on x. So the implementation will probably do this by unification. This first thing, x colon int, introduces a new logical variable, and then you say, okay, and it should be equal to 3. But there can be other places saying x should be equal to 4, and since it can't be both equal to 3 and 4, that means that this could fail. I'll come back to that too. Functions, lambdas, nothing remarkable. You look at this, you think you know what it means. It actually means something different, but it still does the same thing as what you think it does. That's the weird thing about verse. Yeah, conditionals, recursion. Again, you can read it and think you know what it means. Some slight variations here. You could say factorial of 0 is 1, and factorial of n, where n is a positive integer, is something else. Or you could say factorial of 0 or 1 is 1, and n is an integer where n is greater than 1. You can say that too if you want to. And if you can see here that I have carefully made sure that these two clauses don't have overlapping domains. You can, but I won't get into that now. Okay, so now we get to something that it's a little bit different, because there are the other things. I mean, you can do that in any garden variety functional language. Choice. So vertical bar is a choice operator. So you can think of expressions as not yielding a value, but a sequence of values. So 3 is of course just one value. 3 or 4 is 2 values. There's a funny way there of writing when you want no values at all, colon false. We'll come back to that, see exactly why that looks like that. Or 1 dot dot 10, for instance. And once you have the choice thing, you could do sort of things that similar to what you can do with list comprehensions in Haskell. You can say x is equal to 1, 7, and 2. And if you say that, x is not that choice. X will take on the value 1, and then 7, and then 2. So it's the choices are not first-class things. You can't name a choice. But if you say something like this, the variable will go through the different values of the choice. So that's just like that little Haskell list comprehension there in yellow. You can nest them, and then the outermost iterates slower, and the innermost faster. Nothing really strange there either. Yeah, and you don't have to give names to things. You can, this thing x equals 1 or 2, y equals 7 or 8, x comma y. You might as well say 1 or 2, comma 7 or 8. They will iterate in the same order. And you can combine these freely, the choice things. And if you say something like 77 plus false, well, if false has, there are no things, so of course trying to add 77 to everything that there are no choices, that is still no choice. You can do slightly funnier things when you have lenient evaluation. So x is either y or 2, and then y is 7 or 8. So the iteration order goes from left to right, but the data dependency goes from right to left. And this works out. I mean, I'm not saying this is a good way of doing anything, but these sort of consequence of how the lenient evaluation works and what it gives you. And if you try to do something like that in Haskell, that doesn't work, because y is not in scope there in the first position. Oh, by the way, if you have questions, I'm happy to take questions immediately from the audience. That might not work well with the microphone, but if someone has an urgent need to ask a question, please do. It's better than saving it to the end. Okay, so now we come to another unusual choice. There are no Booleans. Instead, there is this failure or success. So we saw already multiple choices. There's more. If there's one or more, that's regarded as a success. And failing is, well, that's failure. And so when you say if E something something, if E succeeds, then we get E1. It doesn't matter if E succeeds in many ways. You only get one version of E1 anyway. And if E fails, then you get E2. And is there anyone here who remembers icon? Ah, there's a couple of old timers here. icon had exactly this. So it's not new, but it's been polished. So if something like x less than 20, that fails, of course, if x is greater than 20, and if it succeeds, then it returns the left operand. And that means that you can do cute things like if 0 less than x less than 20. So less than is right associative. So if x is less than 20 in this thing here, then it returns x, and then you compare that to 0. And things do what they look like they're supposed to do. This is another sort of cute thing that I don't know if it's good or bad, but it works. And you don't really need and an or anymore. You can just use comma, which is the thing that builds pairs. So if either of the two components fails, then of course the whole thing fails. And for or, you can just use choice. And yeah, so you can test for equality. And so we'll see how we'll do it on time, because I also said that this equals is probably unification in an implementation, but you don't really want this comparison with 0 to set x to 0. That would be weird. So there is a notion of rigid and flexible variables that you don't have to think much about it, but it's there. Yeah, so the bottom example here is a one of Tim's favorite examples. He said when he got some BBC Micro or something like that, and he was trying to write a program in BASIC, and he thought this would be the most natural thing to say. If x equals 2 or 3, then I want to do this thing. But of course, that doesn't work at all in normal programming languages. But here it works just fine, because 2 or 3 will be those two choices, and then you will compare x with 2, and you'll compare x with 3. And if one of them succeeds, then yeah, then you go to E1, otherwise E2. I think this is quite neat as well. So here is an interesting aspect of this. So if you have something like an if with a condition, the condition is a transaction. So it either succeeds and then everything in the condition happened, or if the condition fails, then nothing in the condition happened. And so normally you can't say if something happened or not. But once you introduce variables, so here we have a variable that you can assign to called x. It's a mutable variable. And in the condition you say, okay, I'm setting x to 1, and then I'm comparing 0 and 1, so that obviously fails. Well, then we didn't set x to 1. That goes away. So the whole thing there is like a transaction that either all happens or nothing happens. And you can think about sort of a more game example. You move your player, and then maybe you test if something abnormally happened, you were on the wrong side of the wall. Oh, then you shouldn't have moved the player, and that will be automatically undone. But most of this code, move player stuff, is probably written in C++. So in a heroic amount of work, not me, have done this so that it actually will work with C++. You can talk more to Sam here if you want to know more about it, or Phil Pislow if you can find him. He was here earlier. I find this absolutely amazing that it will work with C++, but yeah, it will, at a cost. Okay, so We talked about choices, so you can turn choices into an array or a tuple, whatever you want to call it, and it's called for. And so if you give a bunch of choices to for, you will get an array back with all those elements reified into a concrete data type. So for takes this sort of ephemeral choice things and turns it into a data type where you can actually get hold of all the elements. So nothing remarkable. If you do it for 0 choices, you get the empty array and so on. Order matters, of course. Choices are not commutative. They are associative, the vertical bar operator, but you want the order to matter.
Excuse me?
Yep.
On the previous slide,
Yep.
why isn't the third result a tuple of a Boolean?
Oh, it's because you don't know what false means. You think you know what false means, but it's, I'm sorry, it's one of the weird things about verse. So I mentioned it earlier, colon false is the thing that gives you the empty set of choices. It's, I would not have named this false if I were in charge. I would have named it empty or something like that. But I mean, I'm not paying the bill. Yes, order. You could also go the other way. If you prefix something with a colon, there are 2 ways of writing this, but I'm only showing you this one. If you prefix an array with a colon, that means you get the choices of the things in the array. And so colon and for are sort of each other's inverses. If you do colon and for, you get back the thing you had inside, and for colon e, the other way around. And here you can see the definition of false is just the empty array. Again, I find this is a terrible name, but yeah. Which means that if false is the empty array, that means that colon false is the empty set of choices. There's a slightly more general version of for, which is instead of having for and curly braces, you can say for, and then E1 is the thing that describes what you will iterate over, and the thing in the curly braces are the things that you sort of produce. So for I equals 1 dot dot 3, and then you produce I times I inside. That will sort of be a for loop that iterates 3 times, and you get 3 elements in the array. So for subsumes list comprehensions in language like Haskell, because you can stick predicates if you want in there. So for I equals 1 dot dot 4 and is even I. Oh, I see now that those round parentheses should have been square parentheses, but only the people from Epic will notice the difference. In a few slides, the rest of you will also know that it is a difference. Yeah. You can also have something that fails in the body, which means that to get anything at all, they all have to succeed, otherwise you get nothing. So for I equals 1 dot dot 4, I less than 3, that will be like comparing 1 with 3 and so on. And 2 of those comparisons failed, and that means you get the empty tuple. So you can easily write conditions where you want to sort of filter a bit on the the domain, and then have a range that tests different things. Here's a more bizarre example. Now the body of this has a choice. So for I equals 1 dot dot 3, the body is a choice of 1 or I or I plus 7. And so this behaves like you would think it does. So the for loop is sort of, you unfold the for loop. That means you get a choice of 1 or 8, 2 or 9, 3 or 10, which then in turn unfolds the way you think it should. So you can write really few characters and completely bog down your computer. Here's an example. It's something you should never write, but that doesn't matter. You iterate from, you have A is an array, and you iterate from 0 to the length of the array minus 1, and then you index into the array and add 1 to them. I mean, this is not the right way to write it if you wanted to compute this, but it's just to illustrate. So an interesting aspect is that things you bind in the condition of an if are visible in the then branch, not in the else branch, of course, because you failed with the condition so that nothing would be bound, which means you can write nice things like, if x equals, you index into the array into the ith position, if that's there, if there is an ith element, you'll get that. That will be called x, and you can compute something. If you index outside the array, it will fail, and the if will go to the else branch. So that's kind of neat, I think. So I don't know if there are other languages that has this particular feature with ifs. I mean, I wish more languages had this, because I often want to, when I write C, I often write weird C code like this, that I compute something in the condition and I need to use that. And then I always have to declare the variable outside the if, which means it has more scope than it should have. Now here is an interesting one. So we have an array 3, 7, 4, and we say, okay, I is an integer, and I compute as indexed by I plus 1. What should this be? Well, if I is 0, 1, or 2, that's fine. So we should get those 3. And all the other values of I, you can imagine, means that it fails. So we won't get those. So this will compute to whatever it is, 4, 8, and 5. And so this is usually called narrowing in logical programming. And it's also a cool feature. You can sort of, you don't have to explicitly index things. You can just say, oh yeah, I have this thing, index variable, and that index variable will automatically range over the domain. So what are these arrays and tuples? Well, so to a very good approximation, they are just functions. They are functions from the numbers 0, 1, 2, and up to n minus 1 if there are n elements. So when you write a square brackets I, that is really a function call. I'm calling the function a, which is the array. I mean, it could be a function, but say that a is an array, and you get the ith element. And if you write it with square brackets, it means that yes, this is a function application that is allowed to fail. If you write it with round parentheses, it means no, this application must not fail. And it is the work of the type checker, or verifier as it's called for verse, to prove that if you use round parentheses, it will not fail. So in this example here, the first one, so if I index a with 5, and then I can print x if it's there, otherwise I'll do something else, that's fine. No real proof obligation here. But if I say print a round parentheses 5, it means that the compiler will have to work harder. And if it can't prove that 5 is in the domain of a, then you will get an error at compile time. So Verification is super undecidable, but we don't care. We'll do a best effort. Okay, so now we get to types. Yeah, I have 1 minute to talk about types. So what are types? Well, let me skip ahead a little bit. Types are just ordinary functions. And the function succeeds and returns the input if you're in that type. So a type inverse can be any collection of values. It doesn't have to be something like int. You can make a type of prime numbers, or a type that has 5 and the string hello in it. I mean, these are valid types because it's just a function that says, yes, it's in there, or it's not. So it fails if it's outside the domain and succeeds if it's inside the domain. And you can write your own types that have your own predicates. So of course, this is very undecidable. So let's just go through a small exercise here. We had arrays. Can we make a type of arrays? Well, array of T, that should be the type of arrays where the elements have type T. So there is a type called type, which is the type of partial identity functions. Okay, so what should this look like? Well, I mean, it should then accept an array, and it should test that all the elements have the type T. And how do we do that? Well, you could say for A in the array, we want to test T of A. Cool. And this function, it looks a bit familiar. What if we make it slightly more general and say that, oh, it doesn't have to be a type, this thing T. T could be any function from A to B, which also includes types. Look, it's the map function now. It takes something from A to B, an array, and it loops over the array and returns the new array where you've applied that function. So it means that this array thing is a proper functor. It works both on the type level and the value level. I see that Eric is smiling. So I promised you at least to show you what this x:t really means. So if you write x:t, it really means there exists an x and an I such that x is equal to t applied to I. So when I write x:int and x is equal to 3, I am really saying, well, do there exist x and I such that x is equal to int of I and x is also equal to 3? And yes, we can solve that. If I is equal to 3 and x is equal to 3, then that works out. But if x is equal to foo, no, there is no I that I can pick. So that thing would fail. Failing is not necessarily a bad thing. If you're in a position where you're allowed to fail, like in the condition of an if, that would be perfectly acceptable. If you're in somewhere where you're not allowed to fail, then the compiler would complain and say, no, sorry, you're not allowed to fail here. Yep.
I'm just wondering if that implies that you have one representation of numbers. So can you have a 3 which is an integer and a 3 which is a floating point number?
They have little different suffixes to distinguish between floating point numbers, and so they're really rational numbers, the ones that are written as 3. You have to write 3f for a floating point number. I mean, I don't think it's great, but yeah.
Does that mean the predicate for a type needs to be able to operate on numbers independent of the representation?
I mean, in the worst case, yes, but you'd hope that almost all these type tests will be resolved at compile time. Yeah, I think I need to leave the last couple of minutes. Oh, I should just say that there is a version of Verse if you download Fortnite or rather UEFN, Unreal Editor for Fortnite. You can run programs, and you can run your little code, and then you say start it, and you will drop out of the sky, and you will fall down to the ground, and you can walk up to a monitor, and you can read the result of your program. So that is a version of Verse that does not have all these fantastic features, but there are people programming in it. There are hundreds of thousands of these things called islands that you can make with this. I don't know, do we know how many people are programming in Verse? Thousands. Yeah. And if you make these islands, and anyone can use them, if they become popular, you make money. And there are people who live on making these islands and programming in Verse. So it's not entirely theoretical. Okay.
So we also have the JS panel after that, after this. So if you could come up if you're part of the panel, and we'll do questions with Lennart now.
Does it have a module system?
Yes.
And I guess you alluded to the fact that it bridges with C++, so it also has a story to go either way, I guess?
Yes, I mean, I don't know how much of that is working, but yes, I mean, it's supposed to go both ways.
So you mentioned a couple of times that, like, you know, the billionaire kept, like, you know, pays, and then you just kept, like, implement what they asked for. I've seen that at Microsoft, where Bill Gates was the product manager, and at Facebook, where Mark is the product manager. But maybe sometimes people should just push back, because, I don't know, like, you get maybe weird things if you just do what, you know, the person that pays like wants.
It's pretty easy to push back with Tim if you have sort of a technical argument, and you can say, okay, this is not sound. But if I say, I don't like the word false for this, then Tim will just say, I like the word false.
But I just want to add here, how often are you with the CEO of a company and you say, I don't understand this? Just look at just think of the denotational semantics.
Yes, that's what Tim usually says.
This is our weekly call.
Yes. Tim is a really, really smart guy, and he knows a lot about languages and semantics and so on.
Is the negation of a type also a type? Type is a partial function. Can
yes,
I say not?
I guess that it must be. I mean, all the elements that are not in a type, yes. Can we express that?
Fail, I mean, you know, it's
yeah. Yeah, I think you can, yes.
Can types have mutable variables?
No, types are sets of values, so they don't mutate.
Okay, so every time I look at Verse, I feel like there should be a connection between choice and parallelism. Is that like intuition correct, or am I just misled?
No, not fair.
I mean, I'm sure there are some situations where you could use parallelism. If you have a for loop with a bunch of choices, you could do them in parallel, but that's not sort of the intention.
Currently, Unreal is single-threaded, so anyway.
Is any top or dynamic or for all?
I wish I knew. I'd say it's top.
Yeah, you said that types are sets, so what about types like x equals x arrow x?